Unlocking macOS Forensics, a deep dive into digital investigations. Apple's macOS, known for its sleek design and user-friendliness. But beneath that shiny surface lies a complex operating system with its own quirks, especially when it comes to digital forensics. You see, when we talk about digital forensics, we're talking about uncovering the secrets that devices hold. Think of it like detective work, but instead of fingerprints and footprints, we're dealing with ones and zeros, hidden files, and deleted data. Today, we're diving deep into the world of macOS forensics. We'll be exploring how investigators navigate its architecture, file systems, and logs to uncover those crucial digital breadcrumbs that tell the story of what really happened. Alright, before we get our hands dirty with actual investigations, we need to understand the foundation upon which macOS is built. Think of it like this. You wouldn't start taking apart a computer without knowing where the motherboard, CPU, and RAM are, right? macOS is built on a Unix-based core called Darwin. Now, Darwin itself is a layered architecture, kind of like a cake, but instead of frosting and sponge, we have different software components stacked on top of each other. At the very bottom, we have the kernel layer. This is the heart of the OS, managing the system's resources. Think of it as the engine of your car. Above that, we have the core services layer, which provides fundamental services to the system, like networking and security. Moving up, we have the application services layer, which provides a platform for applications to run on. This is where you'll find things like the frameworks for graphics, sound, and user interface elements. Finally, at the top, we have the user interface layer, the shiny exterior that users interact with. It's like the body of your car, all sleek and stylish. Now, for forensic investigators, understanding this layered structure is crucial. Why? Because evidence can be scattered across these different layers. It's like searching for clues in a multi-story building. You need to know where to look. For example, deleted files might still linger in the file system, hidden from the user but accessible to forensic tools. System logs, which record events and activities, are stored at the core services layer. Understanding where these artifacts reside and how to access them is key to a successful macOS investigation. Now, let's talk about file systems. It's like the filing cabinet of your computer. In macOS, we primarily deal with two types, HFS and HFS+, which stands for Hierarchical File System. HFS was introduced way back in the late 1980s, and it organizes files in a tree structure, like folders within folders within folders. It's simple, but it worked well for its time. Then came HFS+, introduced with macOS 8.1. Think of it as HFS on steroids. It brought support for larger file sizes, more efficient storage, and a bunch of other under-the-hood improvements. Now, both HFS and HFS+ use something called a B-tree structure for storing metadata. Metadata is essentially data about data. Think of it like the table of contents for your files. It tells the system where files are located, their creation dates, modification times, and who has access to them. This B-tree structure is particularly useful for forensic investigations because it allows for quick and efficient searching, even on large drives. It's like having a well-organized library catalog. You can easily find the book you're looking for without having to rummage through every shelf. For investigators, this means they can quickly locate files of interest, even if they've been renamed, moved, or even deleted. The metadata often remains, providing valuable clues about the file's history and usage. Okay, imagine this. You're an investigator and you're handed a Mac with a corrupted or even a deleted hard drive. Game over, right? Not necessarily. See, even when an HFS or HFS+ partition is damaged or deleted, all hope is not lost. Forensic analysts can often recreate these partitions by analyzing the disk's partition table. Think of the partition table like a map of your hard drive. It tells the computer where each partition begins and ends. Even if a partition is deleted, its entry in the partition table might still linger, providing a starting point for recovery. Once the partition table is analyzed, investigators can then search for remnants of the file system structure on the disk. It's like piecing together a jigsaw puzzle, looking for those telltale file system markers that indicate the start of directories and files. But that's not all. Unallocated space, the free space on your hard drive, is another goldmine for forensic investigators. You see, when a file is deleted, it's not immediately wiped from the disk. Instead, the space it occupied is marked as available for reuse. This means that fragments of deleted files or even entire files can often be recovered from unallocated space. It's like finding discarded notes or letters that can reveal crucial information. Tools like SleuthKit are invaluable in this process. They can analyze unallocated space, scan for file signatures, and piece together fragmented data, potentially recovering artifacts that would otherwise be lost forever. Chapter 4. Log Analysis. Deciphering macOS's Digital Diary. Alright, let's talk about logs. Think of them as macOS's digital diary, diligently recording system events, user activities, and application behaviors. They're like the silent witnesses, always observing and documenting what's happening on the system. macOS generates a vast amount of log data, and it's stored in various locations, kind of like having different diaries for different aspects of the system. Some key locations include /var/log//library/log/ and ~/library/log/. Now within these log directories you'll find a treasure trove of information. There are system logs, which record system-wide events like startup and shutdown times, kernel panics, those dreaded blue screens of death, and hardware changes. Then there are application logs which, as the name suggests, log events specific to applications. This can include things like application crashes, errors, and even user interactions within the app. And of course, we have user logs, which track activities specific to each user account on the system. This can include things like login attempts, files accessed, websites visited, and even commands executed in the terminal. Understanding the different types of logs and their locations is crucial for forensic investigators. It's like having a map to a hidden treasure chest. By analyzing these logs, investigators can piece together a timeline of events, identify anomalies, and uncover hidden connections that might otherwise go unnoticed. Chapter 5. Extracting key artifacts from logs. Unveiling the user's digital footprint. So we've got all these logs, but what good are they if we don't know how to extract meaningful information from them? It's like having a library full of books but not knowing how to read. The key is to look for specific artifacts within these logs, pieces of information that can help us paint a picture of what happened on the system. For example, user logs can reveal a wealth of information about user activities. We can see when a user logged in and out, what files they accessed, and even what websites they visited. It's like having a record of their digital footprint. We can also see what devices were connected to the Mac, like USB drives, external hard drives, and even iPhones. This can be crucial in cases where data exfiltration is suspected. Shared locations like network shares and cloud storage services are also logged, providing insights into where data might have been moved or shared. It's like following the digital breadcrumbs. And let's not forget about recently accessed documents. macOS keeps track of the files and applications that have been used recently, which can be a goldmine for investigators trying to understand a user's recent activities. By analyzing these log entries, investigators can start to build a timeline of events, identify patterns of behavior, and ultimately, uncover the truth of what transpired. Chapter 6. Applications and User Preferences, Unmasking Hidden Configurations. Alright, let's delve into the world of applications and user preferences. You see, macOS stores a wealth of information about your applications and how you use them, all neatly tucked away in configuration files. These configuration files, often with the .plist extension, are like little treasure chests of information. They contain user settings, application preferences, and even specific configurations for different apps. For example, Safari, Apple's web browser, stores your browsing history, cookies, and even saved passwords in a file called history.db. Now this file is not in plain text, it's in a database format. But with the right tools, investigators can access and analyze this information, revealing a user's web browsing habits. Then there's Finder, the macOS file manager. Finder uses ds_store files to store metadata about directory contents like icon positions, view settings, and even file comments. These files can be found in almost every directory on a Mac, and they can reveal a lot about how a user organized and interacted with their files. And it's not just system applications. Third-party apps also store their configurations and user data in these .plist files. So for example, if you're investigating a case involving a specific messaging app, you might find valuable information like chat logs, contact lists, and even deleted messages within the app's configuration files. Now analyzing these .plist files can be tricky. Some of them are in plain text while others are in a binary format. But fear not, there are tools for that. Plist Viewer and other hex editors can be used to decode these files and extract valuable information. Unlocking macOS Forensics, the wrap-up. So there you have it, a glimpse into the world of macOS Forensics. We've explored the layers of its architecture, the intricacies of its file systems, the silent whispers of its logs, and the hidden configurations of its applications. It's about piecing together the digital breadcrumbs, connecting the dots, and ultimately, uncovering the truth. It's a meticulous process requiring precision, attention to detail, and a deep understanding of how macOS operates. But with the right tools and techniques, investigators can unlock a treasure trove of information even from devices that seem to hold nothing but silence. Thanks for joining me on this deep dive into macOS forensics. If you found this insightful, don't forget to smash that like button, subscribe to the channel for more digital forensic adventures, and let me know in the comments what other tech mysteries you'd like us to unravel. Until next time.